Okay, this question gives you a diagram of 4 different pictures, and it says to tell you whether or not they are mixtures or pure substances, and if they are mixtures, are they heterogeneous or homogeneous? So let's see if we can identify the pure substances and the mixtures first, and then we'll go back and decide whether or not the mixtures are heterogeneous or homogeneous. Well, let's take a look at the first one. The first one, I have red dots and black dots. They're not together. They're just a little bit apart, but they're kind of what would you say? They're mixed in with each other. And so since they're red dots and black dots, separate red dots, separate black dots, but they're all intermingled with each other, then what we would say about this one is it's a mixture. What about the next one? The next one, it's just a collection of black dots. And so the only thing that's present is a black particle. And so this one is definitely a pure substance. Okay, the next diagram shows black particles and red particles. They're not mixed like they were in the picture on the far left, but they are mixed in the sense that in the collection of particles, there are both black particles and there are red particles. Now, you can also see that there is some red particles and some black particles intermingled in the opposite color. And so I'm hoping what you're doing is seeing that and coming to the conclusion that it's a mixture. What about the last one? Well, what we have in this case is a collection of particles, and the particles consist of red dots next to black dots. And so the unit that is the particle is actually a red dot connected to a black dot, or they're bound together is another way to say it. So these are not mixed together, they're connected together, and that still means that they are a pure substance. And so once you get to start to talking about what a molecule and a compound is, you realize that this is a compound. It's got 2 different types of atoms in it, but it's still a collection of red-black units. And because it's a collection of red-black units and nothing else, it's a pure substance. Now, what about the mixtures? Are they heterogeneous or homogeneous? Remember, a homogeneous mixture has the same composition throughout, and a heterogeneous mixture doesn't. And so the 2 examples that I go to are for a heterogeneous mixture, it's kind of like oil and water. And for a homogeneous mixture, the go-to example is Kool-Aid, right? The sugar and the food coloring all mixed together with the water. That's a homogeneous mixture. Well, what do we have here? What about the mixture on the left? The red particles and the black particles are evenly dispersed around each other. So the composition is the same. So this is a homogeneous mixture. What about the mixture over on the right? Well, I have a red and black interface. And I do have some red particles mixed with the black particles and black particles mixed with the red particles, but they're not mixed evenly. The distribution of the particles is not the same throughout. And so this one is a heterogeneous mixture. Okay, that's all there is to it.